right, so parts of a quadratic function. Remember, a quadratic function, what is the parent function? We talked about this last week. You need to look back at your notes to see where we talked about the parent function. Do that, but what is the parent function? Y equals x squared. Take a point, bless you. Y equals x squared is the parent function. And we can also write a quadratic in standard form, which is y equals ax squared plus bx plus c. Now, this standard form is very important for how we're going to determine algebraically our parts. Bless you. So this is standard form. Amelia, I think it's done now, babe. Kind of shake it, make sure. Oh, no. Okay. All right, so what is a parabola? We've talked about this word before.
Yeah, we talked about
Mm-hmm.
It's like the graph
Of a quadratic. Yeah. Both of you take a point. Good. So this is the graph of a quadratic. And does it look like a U or a V? U. It looks like a U. Good. Take a point. And how many different ways can it look? Or I mean, two. It can open upwards or downwards. Good. So it can look like these, or it can look like these. Yeah. Are we still on? Yeah. Okay, good. All right. The next part is the axis of symmetry. Now, what does the word symmetry mean? Same on both sides. Good. Both of you take a point. You cannot use the word to define the word. Just a fun fact there. All right. So the axis of symmetry, it cuts the parabola in half. And think about how our parabolas look. What axis is it going to pass through if it cuts our parabola in half? The x-axis. Good. Take a point. Because our parabola opens up, right? It looks like this. So if you cut me in, like, I'm my own axis of symmetry. I'm vertical. It's going up and down, so that means it's going to go through the x-axis. So this is a vertical line, or a vertical imaginary line. It passes through the x-axis. And we have an equation for it. The equation to find is x equals the opposite of b divided by 2 times a. So that's where standard form comes in. You take whatever this is, whatever b happens to be when it's in standard form, you take the opposite, you divide it 2 times the number in front of x squared. Which we're going to practice doing today. Super fun. Now, what is the vertex? Highest or lowest point. Take a point. All right. Highest or lowest point on the parabola. And do you think that the axis of symmetry passes through our vertex? Yes, it would have to. So your axis of symmetry is the x value of your vertex. So we're going to say AOS is x value of vertex. How would we get our y value then? Because it's a coordinate, right? So how would you get your y value? If you know what x is, how do you get your y? If we knew what x was here, how did we get our y values? we plug it into the parent function. Here, if we knew what our x was, how did we get our y's? Plugged it into the equation right here. So when you're looking for your when you're looking for your vertex, you plug in your axis of symmetry to get your y value. So plug in AOS to get y. What is a y-intercept? On the y-axis, good. Take a point. So where the parabola crosses the y-axis. And what does x equal whenever we are finding our y-intercept? We've done this before. It's the same thing as when you have a linear. What did x equal in a linear when we had our y-intercept? 0. Take a point. So x equals 0. Your y-intercept, when it's in standard form, is also c every single time. So if I give you an equation in standard form, look for the constant. All right, what is our x-intercept or our roots? Where it crosses the x-axis, good. And what else do we call those? We call them x-intercepts, roots. There's 2 other names. Zeros and solutions. Good, take a point if you said that. So where the graph crosses the x-axis, also known as solutions or zeros. And what does y equal on those? 0. Good. Take another point. Bless you. All right, the next word says maximum. What is a maximum? When the vertex is at the highest point. Good, take a point. And what must our graph look like for us to have a maximum? Is it a U or a mountain? It's a mountain. Awesome. So it would look like this. That's a maximum. Which means what sign is in front of x squared? When it opens downward, what sign is in front of x squared? A negative. Good. Take a point. All right, what about a minimum? The lowest point, when the vertex is the lowest point. Take a point. And how does it open whenever we have a minimum? Take a point. And what is x squared positive or negative when it opens upwards? Positive. Good. Take a point. All right, and our last two very important words are domain and range, which mean the same thing that they've meant the whole year. So what is domain? What are we muttering at me? Your x coordinates. Good. So your domain is still your x values. And with a quadratic function, you can plug in any x value in the whole entire world, which means your domain is all real numbers. Or you can write that as your symbol. I feel like I can't see the light purple. Oh, it's just my angle. Can y'all see it okay? All right, it's just this weirdo angle because I don't have a long cord. All right, so if domain is our x values and we can plug in anything, well, let's write whatever we plug in. Whatever we plug in. What's our range? The y values. Good, take a point. Also known as what? If x is your input, what's your range? Output. Good. Now, are we going to get out any number in the entire thing, or are we going to get out a specific set of numbers? A specific set, because our y values do what whenever we make a parabola? They repeat. Good. Take a point. All right, this is a specific set. All right, we're ready to identify? See what's happening in this thing? Yes, no, maybe so? All right, flip the page. I'm going to finish separating my sections because now that's beautiful. It makes my soul happy. All right, so what we're going to do in each of these is we're going to identify the axis of symmetry where it crosses the x-axis, the vertex, y-intercept, x-intercepts, all the things. And then on that handy-dandy piece of paper two pieces of paper that I gave you, we're going to do the same thing. And it shouldn't take long. All right, so our axis of symmetry. Now, I'm going to say, even though these lines are kind of faint, that it doesn't cross at an exact coordinate. What do you guys think? I feel like right here is 1. And then right here is 2. So where would our axis of symmetry be at? 1.5, roughly. All right, so I'm going to draw, and this is how you draw your axis of symmetry. You draw a vertical dotted line, and you write x equals 1.5. Now, our vertex is down here at the bottom. And remember, your vertex, always the x-coordinate is your axis of symmetry. So it's going to be you need to write a 1, Blair. 1.5 comma, and then we need to see how far we go down. What do you guys think it is? We're trying to find the y value of this point right here. That's our vertex, right? So you would go right 1.5 and down 1, 2, 3, I'm going to say 4. What do you guys think? So it's 1.5, negative 4. That's how you write your vertex. Now, your y-intercept is where it crosses the y-axis. So what is that coordinate? Positive 3 or negative 3? Negative 3. So it's 0, negative 3. And make sure you write it as a coordinate. How many x-intercepts do we have? 2. We have one right here. And then one right here. So let's guesstimate the one on the left. What do you guys think that's at? Negative 2. Okay. Negative 2, 0. And then what about the one on the right? 4, 0. Okay. When we have a better graph, we'll be able to see that they're the same distance away from the axis of symmetry. Just to let you guys know for the next time. All right, do we have a maximum or minimum this time? Minimum. And what is our domain always going to be that we just said a second ago? All real numbers. Now, this is what I meant by a specific set on your range. Your range is every single y value that hits this curve. Now, it's not going to be any y value below the curve. So what is the smallest y value that we have? -4. And then it opens up. So are all the other y values greater than or less than -4? Greater than. So the way you write your range, write it as a squiggy, and you say y when y is greater than or equal to -4. Now, the reason we picked -4 is because that's our y value of our vertex. So this and this are always going to match up. And then your x and your axis of symmetry are always going to match up. And that's how you check to know that you've done it right. All right, let's look at problem 2, and then we're going to talk about the worksheets that you have. What's our axis of symmetry on this one? Oh, we can see this one much better. So x equals -1. Your axis of symmetry is just x equals. It's just one number. And then your vertex is the x coordinate and the y value of wherever that is. So where is our vertex at? I love it when we mutter at me. What's our y-intercept this time? What's our y-intercept? 0.6. Bless you. What are the x-intercepts? How many do we have? 2. Those are also known as solutions, zeros, and roots. Good. All right, so what's the one on the left? -3, 0. And the one on the right? 1, 0. Because if it was 0, 0, you know what words I'm trying to say to you. Good job. Whoa, okay. All right. Is it a maximum or minimum? It's a maximum. And what is our domain? All real numbers. And our range this time, is our graph opening up or opening down? Down. So it's going to be less than. And what is the highest y value that we have? 8. So it's y when y is less than or equal to 8. Now, do the y value of our vertex and our range match up? Does the x value of our vertex and our axis of symmetry match up? Then hot dog, we did it right. All right, get out the 2 worksheets that I just passed out to you a second ago. Need to go grab some for myself. All right, so the first one, it says for each graph, identify the vertex, axis of symmetry, domain, and range. So that's what we just did, right? So let's look at number 1. What is the vertex? And this is how you should write it. Vertex, axis of symmetry, domain, range. And I would write it like that every single time. All right, what's our vertex here? 0, 0. What's our axis of symmetry? X equals 0. What's your domain? All real numbers. And what's your range? Good, take a point. Y when y is greater than or equal to 0. Ta-da, that's all you do. So exactly what we just did, right? It's crazy. Does anybody have a question?
Yeah.
You do have a question?
Well, I don't know, but I don't mind.
What's your question, Boo Boo?
No, I got it.
Are you sure? Are you telling me that to make me happy?
Yes and no.
What is your question then?
I mean, I got it now.
Oh, my ham sandwich. What was your question then?
I have to get 0, but then I realized
You looked at the graph. All right, the back says identify a minimum or maximum. Easy peasy, right? But I want you to write it as a coordinate. So I want you to tell me that this one is a minimum. Okay, Blair. I'm just going to write min because I am struggling. And then tell me what the vertex is. So what's our vertex here? -3, 1. Good. Take a point. Ta-da! That's all you do there. And the last one, find the zeros. So find where it crosses the x-axis. And if you have to approximate, that's fine. All right? Ready, set, go. Yes. It's homework if you don't finish.